Okay, today we're going to be talking about probabilities, and these probabilities are going to happen with permutations and some combinations. So first we need to talk a little bit about a few mathematical terms. So factorial. So factorial is when you have a number, say I'm going to use the number 4, factorial. And you write that as a product of 4, and then you reduce by 1, reduce by 1, reduce by 1 until you get to 1. Okay, so 4, 3, 2, 1. Notice 0 factorial is 1, which I find kind of interesting. Anyway, so that's what a factorial is. Now, what probability is? The number of possible outcomes over the number of favorable outcomes. So the number of favorable outcomes versus the number of possible outcomes. Okay, our first example. Eli and Mia, along with 30 other people, sign up to audition for a talent show. Contestants are drawn at random to perform for the judges. What is the probability that Eli will perform first and Mia will be called second? Okay, so first we have to figure out our number of possibilities. So we have 30 people that we're lining up. So that's 30 factorial. The number of favorable outcomes. Well, we want Eli and Mia to go first. So we take 30 minus our 2 people to get 28. There's 28 factorial left over for everybody else. So 28 is 28 times 27 times 26, and dot, 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 all the way till I get to 1. And then let's look at 30. 30 times 29 times 28, if I could write the 28 correctly. 28 times 27 times 26, you see what's happening here, all the way to 1. Well, what cancels? The 28, 27, 26 on the top, 28, 27, 26. So really, my answer here is 1 over 30 times 29, which equals 1 over 870. Now, quite honestly, there's another way that I think about this. Okay, so let's look at this. Probability that Eli goes first. Okay, Eli is 1 out of 30 people. We multiply that by the probability that Mia is going to go second. So Mia, Eli's already gone. I have 29 people left over. There's one possible person, Mia, who we want to go second. Okay? Okay. Permutation. In a permutation, order matters. So ordering students in a line, arranging students in a line. Think about the Hoffman cafeteria line. If we all lined up as one in one single file line, okay? How many different permutations could I have there? And our permutation formula is written as NPR, and it's given by this formula. I'm going to show you how to do this in your calculator. Remind me in class. I will show you how to use your calculator for this. Okay, because quite honestly, I don't remember the formula, so I'm going to leave you. I'm going to let you guys just use your calculator on it. Okay, so let's look at our second example here. Okay, so there are 12 puppies for sale at a local pet shop. 4 are brown, 4 are black, 3 are spotted, 1 is white. What is the probability that all the brown puppies will be sold first? So our number of possible outcomes is, we have 12 total things. We are putting 4 of them in line. And in my calculator, I do that math. Remind me again in class. And then our favorable outcomes. Is 4 things, because I want 4 brown puppies and they have 4 spots to fill, and that is 24. Another way to think about this, and this is what our book did, is 4 factorial, because I have, for the first spot, I have 4 possibilities. For the second spot, I have 3, then I have 2, then I have 1, which is technically 4 factorial. So our answer, the number of favorable, is 24 out of 11,880. When I reduce that fraction, I get 1 over 495. Okay, permutations with repetition. Okay, so if things repeat, so a box of floor tiles contains 5 blue, 2 gold, 2 green tiles in a random order. Okay, so my total amount, so this n up here, this n factorial is my total amount. What's the total amount of things I have? Total amount of things is 9. So my total number of possibilities is 9 factorial divided by whatever repeats. I have 5 repeats, 2 repeats, and 2 repeats. This works out to be 756. So again, okay, this 5 was that 5. This 2 gold was that 2. And then my 2 green is right there. Okay, so a box, I select the tiles at random. I want this design. Well, that's one design. That's my number of possibilities out of 756. Okay. Okay, moving along. Circular permutations. So if you have n number of things in a circle with no fixed point, so nothing, there's no like the chairman has to sit in seat 1. That would be a fixed point. Okay, or I have to sit in seat 7. There's no fixed point. How many different ways can I arrange things in this? And you can look at that as n factorial divided by n, or n minus 1 factorial. So in our example here, I have 8 students that sit randomly in this seating, and there's no fixed point. So I have 8 minus 1 factorial, which is 7 factorial. So the number of ways that I can have this is 5,040. Okay, what's the probability? Well, there's 1 outcome out of my 5,040. The next example, I purchase a box of crayons. The crayons are packaged in a random order. What is the probability that the crayon to the far left is red? Okay, well, this is a fixed point. So I have 1 possibility out of 8 crayons that I'm moving around. So my probability is 1 out of 8. So a combination. Combination, order doesn't matter. So I think of groups. I think of the groups in our classroom. Okay, the groups in our classroom, the order doesn't matter. Or, because I'm always thinking about food, think about a pizza. A pizza with sausage, onions, and mushrooms is the same thing as a mushroom, sausage, onion pizza. It doesn't matter. Okay, so a number of combinations is given, again, by this formula. You're welcome to memorize the formula. Again, I'll show you, remind me in class, I'll show you on your calculator how to do this. And I apologize, I hope you guys just didn't hear my cat meow. She must not like the word combinations or calculator. That or she's hungry. Okay, one more example here. A set of alphabet magnets are placed in a bag. 5 magnets are drawn at random. What is the probability that they will be the letters A, E, I, O, U? Okay, so my favorable outcome. I have one favorable outcome. My number of possible outcomes. Doesn't matter what order I'm picking them in. There's 26 letters in the alphabet. I'm choosing to pick 5 letters. 6, 5, 7, 8, 0. Again, remind me in class to show you this in your calculator. So you have 1 over 6, 5, 7, 8, 0. Okay? So that is my probability. Okay, so that is my video on probability with permutations and combinations. Thank you for watching.